Welcome to the DIY Honda Garage channel. This presentation focuses on DTC P2826, which indicates a low input from the line pressure solenoid valve A in a 2011 to 2015 Honda Civic. The line pressure solenoid valve plays a crucial role in regulating the pressure within the transmission, ensuring smooth operation and shifting. When this fault occurs, the engine control module, ECM, commonly known as the PCM, receives insufficient signals from the valve, triggering the DTC. This issue is primarily electrical in nature rather than mechanical, meaning that it often involves checking wiring and connectors rather than transmission hardware. Understanding the diagnostic process and performing the necessary troubleshooting steps is essential to accurately resolve this issue and to restore proper function to the vehicle's transmission system. DTC P2826 points directly to a problem with the line pressure solenoid valve A. This component is located within the transmission assembly, and its primary function is to control fluid pressure necessary for optimal shifting between gears. The line pressure solenoid valve A regulates hydraulic pressure, which impacts how smoothly the transmission shifts. If this component fails or sends low input signals, it can cause erratic shifting or even prevent the vehicle from shifting into gear altogether. The component is wired to the powertrain control module, PCM, which interprets the signals sent by the solenoid. This fault code highlights the need to focus on electrical connections rather than transmission hardware, leading us to assess wiring and solenoid integrity before any mechanical inspection is considered. The causes of DTC P2826 are thoroughly examined to ensure accurate diagnosis. Firstly, an electrical circuit issue is likely, signaling a break or malfunction in the communication between the line pressure solenoid and the PCM. The second potential cause is a faulty line pressure solenoid valve A, which, if jammed or malfunctioning, would impede proper function. Wiring problems, such as frayed or broken wires connecting the solenoid to the PCM, are also a possibility and should be investigated carefully. Another aspect to consider is the fused circuit failure, particularly focusing on the number B7 fuse. Understanding these causes allows the technician to narrow down the problem efficiently during inspection and testing. And common symptoms associated with DTC P2826 provide further insight into the problem at hand. Drivers may experience erratic shifting or experience significant delays between gear changes, which can be alarming and hazardous while driving. Additionally, the vehicle might struggle to engage gears or may become stuck in one gear, rendering it difficult or impossible to drive. Transmission overheating can also occur due to improper fluid pressure management, which could lead to further complications if left unaddressed. Persisting warning lights on the dashboard, particularly the check engine light, commonly indicate an issue in the transmission, leading drivers to seek professional diagnostics. Recognizing these symptoms is key in understanding the urgency of the situation. The first step in troubleshooting DTC P2826 involves initial checks to verify the problem. To begin, the technician turns the ignition switch to on, number 2, which powers the vehicle's electrical system. Once the ignition is engaged, clearing the DTC using the Honda Diagnostic System, HDS, is crucial to reset the system. Following this, the engine must be warmed up to its normal operating temperature, which is signified by the activation of the radiator fan. This ensures that the system is functioning under typical conditions. After performing these steps, the technician will inspect the HDS for any pending or confirmed DTCs. If the DTC P2826 reappears, the failure is confirmed, prompting further inspection. If not, it may indicate an intermittent fault, necessitating checks for shorts in the circuit. In the second troubleshooting step, focus shifts to the electrical system. specifically fuse number B7, which is 15A, and located in the under-dash fuse relay box. Checking the condition of this fuse is crucial, as it plays a significant role in the circuit connected to line pressure solenoid valve A. If the fuse is not blown, it indicates that the power is reaching this section of the circuit. However, if it is blown, replacing it is necessary, followed by a thorough investigation for any shorts to ground in the circuit that could cause it to blow again. This step is vital because a blown fuse can interrupt the flow of electricity essential for the solenoid's operation, triggering the DTC P2826. For the third troubleshooting step, the ignition should be turned to lock 0 to ensure safety while working with electrical components. The technician will then jump the SCS line using the HDS, after which PCM connector A49P must be disconnected. This action isolates the system for voltage measurement. The ignition is then turned back to on 2 to check the test points between IG1 missole, which is critical for the solenoid operation. The technician must measure the voltage between test points 1 and 2. One part connects to the PCM connector A and the other to a body ground. If battery voltage is present, it indicates that the IG1 missole wire is intact, allowing for progression to the next step. If voltage is absent, it confirms an open circuit issue that necessitates repairs before further diagnostics. In the fourth troubleshooting step, again, the ignition should be switched to lock 0 for safety. The technician will disconnect the line pressure solenoid valve A using its 2-pin connector. This disconnection allows for the measurement of internal resistance, which is crucial for determining whether the solenoid is functioning properly. Using a multimeter, the technician will measure the resistance between the designated test points on the solenoid connector, while ensuring the circuit is not energized. The expected resistance value should range between 13.8 to 17.1 ohms. If the value falls within this range, it confirms that line pressure solenoid valve A is operating correctly, allowing the technician to proceed to the next troubleshooting step. However, if the resistance is outside this range, it would necessitate replacement of the solenoid valve. During the fifth troubleshooting step, the technician resumes by jumping the SCS line with the HDS for continuity testing. The next action requires disconnecting PCM connector B49P to isolate parts of the circuit. The focus during this step is on the PLA line, which connects the line pressure solenoid A to the PCM. The technician will check for continuity between specified test points, confirming that the electrical connection is intact. If continuity is present, it indicates a short to ground in the PLA wire, which necessitates repair. If continuity is not present, it validates that the wiring remains intact, resulting in updating the PCM software or substituting with a known good unit to ensure proper operation. The final repair verification step involves several critical actions to ensure that all repairs have been made correctly. First, the technician should reconnect all previously disconnected connectors, ensuring that each connection is secure and free from corrosion. The ignition switch is then turned to the on-2 position to reactivate the electrical system. After clearing the DTC using the Honda Diagnostics System, HDS, the engine must be warmed to its normal operating temperature again. Finally, the technician will shift the gear lever to D with the brake pedal pressed and monitor the OBD status for the presence of DTC P2826. The expected outcome is that the system will indicate passed, signifying successful repairs. If failed or not completed appear, further investigation will be necessary to pinpoint unresolved issues. Preventive maintenance plays a crucial role in avoiding future occurrences of DTC P2826 and similar electrical faults. Technicians and vehicle owners should routinely check the electrical system for signs of wear or degradation. Particular attention must be paid to wiring and connectors associated with the line pressure solenoid and PCM. These components are subject to heat and vibration, which could lead to failure over time. Regular maintenance of transmission fluid levels is essential, as adequate fluid is crucial for optimal hydraulic pressure management. Furthermore, staying informed about software updates for the PCM and reprogramming when necessary can prevent communication issues that may arise from outdated firmware. Such proactive measures can significantly extend the life of the vehicle's transmission system. In summary, addressing DTC P2826 requires a strong emphasis on electrical system diagnostics rather than mechanical components. The line pressure solenoid valve A is central to the fault, and careful testing methods must be employed to ascertain its functionality. Inspection of wiring and connectors is equally important, as failures in these areas can lead to persistent issues. Technicians should conduct all troubleshooting steps methodically, ensuring to clear the DTC and verify repairs through comprehensive diagnostic procedures. Overall, implementing preventive maintenance measures will help mitigate future issues, ensuring that the vehicle operates efficiently and reliably. Understanding and addressing these concerns leads to more consistent and smooth performance of the Honda Civics transmission. Please like and subscribe to the channel. See you next time!